In this question, we need to find the ratio of masses. So it's a pulley mass problem. Two masses are there and their acceleration is given. So let's consider the acceleration is in this way, g by 8. So we'll do the free body diagram of mass m1. So for m1, the tension will act upward and m1g, gravitational force, will act downward and its acceleration is upward, g by 8. So if we write the equation, then we will get, oh, this is tension, T minus m1g, which is equal to m1a, where acceleration is g by 8. Let it be. Next, we'll do the same thing for mass m2. For m2, the tension is again upward, gravitational force m2g, it is downward, and we consider the acceleration is also downward, g by 8. So if we write the equation for it, we will get m2g minus tension, which is equal to m2a. So this is first equation and this one is second equation. From this we need to find the ratio of masses. So we don't know about the tension. Let's add two equations so that the tension gets cancelled. We'll get m2 minus m1g, which is equal to m1 plus m2 into a. I'll substitute a here. So m2 minus m1g, which is equal to m1 plus m2 into g by 8. This g and this g will get cancelled. We'll multiply this 8 on the left side. So we'll get 8m2 minus 8m1 equal to m1 plus m2. So we'll keep m2 one side and m1 other side. So 8m2 minus m2, which is equal to m1 plus 8m1. So we get 7m2 equal to 9m1. So m1 by m2 will become 7 by 9. This is the ratio of the mass, but if we look at the option, there is no option which is 7 by 9. Since they specified only the ratio of masses, they haven't mentioned whether it is m1 by m2 or m2 by m1. So we can write m2 by m1 also. And this is 9 by 7. And this option is there. So this is the correct answer. In the question, they should have mentioned whether it is m1 by m2 or m2 by m1. Since they haven't mentioned, so we can check for both. In this case, it is correct for m2 by m1. In this question, we need to find the torque on a rectangular loop. Magnetic field strength and direction is specified. The dimensions of the rectangular loop is specified. And current is also specified. So first, let's consider the axis. This is my z axis, and this is y. And positive x-axis is going into the screen. So this cross means it's going into the screen. Like this we can consider. Now let me draw the loop. It is placed in YZ plane. So on the plane what you are seeing, it is placed. It is placed like this, and they have specified the current direction. So with respect to negative x-axis, which means what we are seeing now, because negative x-axis is something which is coming out of the screen. So whatever we are seeing, it is with reference to negative x-axis. And the current is anti-clockwise. Current is going in this way, anti-clockwise. Fine. So let's write the magnetic field. B is 2 into 10 power negative 3 Tesla, and the direction is positive y. So which means J cap. And we need to find the torque. So torque can be written as magnetic moment times or cross product of magnetic moment and magnetic field. So magnetic moment is I times A, where A is the area vector and area vector is in the direction of the magnetic field given by this current at the center. So at the center, the magnetic field will be out of the page. So which means it is in negative x-axis direction. So current I is 5 ampere and area of the loop is going to be 0.1 into 0.2 because the dimensions are given in centimeters. So 0.2 into 0.1 and the direction is going to be negative x-axis, so negative I cap. This is 0.1 negative I cap. Now we can find the torque M cross B. So M is 0.1 into negative I cap cross product with 2 into 10 power negative 3 J cap. So I cap into J cap will be K cap, but here negative is there. So we will get negative K cap. That's the direction of the torque. Magnitude is 2 into 10 power negative 4 Newton meters. So negative K cap means negative z axis direction. Then second option is correct. This question is related to simple pendulum as well as error analysis. So here there is a simple pendulum and its length and accuracy is given. So length is 20 centimeter and accuracy, let it be delta L, which is 2 mm. Can convert this into centimeter, 0.2 centimeter. And time period of 50 oscillation is given. So which means time period for one oscillation will be 40 by 50 seconds. Similarly, the accuracy is going to be 1 by 50 seconds. We need to find the accuracy of finding acceleration due to gravity. So, time period of simple pendulum can be written as T equal to 2 pi under root L by G. From this, I can write G equal to, we can square both the side and rearrange things. It will become 4 pi squared L by T square. Now we can start with relative error. So error in finding gravity, delta G by G, is going to be, like you might have learned this, if there is a parameter C, if this can be written in terms of A into B power n, then the relative error in finding C equal to delta A by A plus n into delta B by B. Even if this n is negative, we have to put positive only because errors are always additive. So in this case, we get 2 into delta T by T plus delta L by L. So 2 into delta T by T. So T is there, delta T is there. If I write, I will get 1 by 40. So that both the terms have 50 in the denominator, that will get cancelled. Plus delta L by L, 0.2 by 20. So L and delta L. We simplify this, we'll get 20 into 1.2. This is relative error. In the question, they are asking percentage error. So delta G by G percentage, which is equal to 1.2 into 100 by 20 percentage. So this will become 5. Yeah, we'll get 6%. So the percentage error in finding gravity, acceleration due to gravity, is 6. Two point charges are placed at a separation of r in vacuum. So this is the first case. In this case, the force is given by F equal to 1 by 4 pi epsilon naught Q1 Q2 by r squared. Next, what are they doing? The charges are placed in a medium which is having dielectric constant K equal to 5 and the separation is r by 5. So it's going to be something like this. So separation is r by 5, charges are still Q1, Q2. So let's consider in this case the force be F dash. So F dash equal to 1 by 4 pi K times epsilon naught Q1, Q2 by r by 5 square. So this will become 1 by 4 pi epsilon naught f5 q1 q2 r squared by 25. It will come, that 25 I'll write here. So this 25 and 5 we can cancel. Then we get f dash, which is equal to 5 into 1 by 4 pi epsilon naught q1 q2 by r squared. This 1 by 4 pi epsilon naught q1 q2 r squared is nothing but force. So it is going to be 5L. Voltage and current of a LCR circuit is given. We need to find the average power. So average power of LCR circuit can be written as IRMS VRMS into cos phi. So IRMS, root mean square current, is nothing but Imax by root 2. Similarly, VRMS is equal to Vmax by root 2. And here phi is the phase difference between current and voltage. So here the phase difference is pi by 3. So Imax is 10 ampere, Vmax is 20 volt. Let's substitute everything. 10 by root 2 into 20 by root 2 into cos pi by 3. So it is 10 by root 2, 20 by root 2. Cos pi by 3 is 1 by 2. So if we simplify, we get 5. Root 2 is 2 and 20 by 2 is 10. So we get 50 watt. Fourth option. This question is related to polarization. Initially, an unpolarized light is incidenting on a transparent medium from air with angle of incidence 60 degree, and the reflected ray is completely polarized. Here, that point you should note. We need to find the angle of refraction in the medium. Let's draw it. Consider this is a medium, and this is the normal line, a perpendicular line to the medium. Here we have the incident ray. So let theta I be the angle of incidence. In this case, it is 60 degree, and this is the reflected ray. The angle of reflection is theta r. Now some amount of ray will get refracted as well, and let this r be the angle of refraction which we need to find. And here one point is mentioned: the reflected ray is completely polarized. When this will happen? If you remember Brewster's law, when the angle of incident is equal to Brewster's angle, then the reflected ray will be completely polarized, and also the angle between reflected ray and refracted ray is going to be 90 degree. So this will be 90 degree. Let me just take that part alone. This is the normal line. This is a reflected ray, and this angle is going to be 60 degree, because based on law of reflection, angle of incidence is equal to angle of reflection. Since incidence is 60 degree, reflection should be 60 degree. And this is a refracted ray, and this angle is going to be 90 degree. We need to find this r. So when we have a straight line, if we find the angle, it is going to be 180 degree. So in this case, we have this vertical straight line. So that angle is 180 degree. That can be represented as 60 degree plus 90 degree plus r. So like this part and this part, then this part, which is going to give this one. So from this I can find r, that is 30 degree. So angle of refraction is 30 degree. We need to find speed of sound in oxygen at standard temperature pressure. So the speed of sound in gases is given by V equal to gamma RT by M. So here gamma is adiabatic constant, which is given in the question. R is gas constant. T is the temperature. So here it is mentioned standard temperature and pressure. STP means standard temperature and pressure. So here the temperature is 0 degrees Celsius. Always we have to write the temperature in terms of kelvins. So it is equal to 273 Kelvin. And standard pressure is 1 atm. Of course, here pressure is not needed, but you should know. Yeah, and second one is this mass. Here we need to find the um, molar mass of oxygen, and this is not oxygen atom, this is the oxygen molecule. So its molar mass is going to be 32 gram per mole. If I convert this into kilogram, then it will become 32 into 10 power negative 3 kg per mole. Now let's substitute everything. So gamma is 1.4, gas constant 8.3, and temperature 273 Kelvin. So here it's more important to write in terms of write the temperature in terms of Kelvin, and this is 32 to 10 power negative 3. So if we find the answer, it will come around 315 meter per second. So here they have mentioned approximately. So we can see the value which is close to 315. It is going to be 310. We need to find the total internal energy of a system. That system consists of 8 moles of argon gas and 6 moles of oxygen at temperature T. So if we have a gas at temperature T, then its internal energy, we can write it as NCVT, where N is number of moles, CV is specific heat capacity for constant volume, T is the temperature. Since we have two gases, the total internal energy we can write like this: N1 CV1T plus N2 CV2 into T. So here the main task is to find the CV1, CV2 for the gas argon and oxygen. So argon is a inert gas. It is a monoatomic, and it will have only 3 degrees of freedom. Generally this CV we can write it as N by 2 into R, where N is the number of degrees of freedom for that particular molecule. So since it's a monoatomic, which means it can move only along 3 axes, X, Y, and Z. Other than that, it doesn't have any motion. So the N value, the number of degrees of freedom for argon gas is 3. So CV value for argon gas will become 3 by 2 R. And whereas when we consider oxygen, it is a diatomic. So like 2 atoms are there. In a single molecule, 2 atoms are there. It will be connected like this. So these 2 atoms can move along X, Y, Z axis. There is no constraint. So it will have 3 translational degrees of freedom. So the movement along X, Y, and Z axis is known as translational motion. So it has 3 translational degrees of freedom. That is fine. Along with that, this molecule can rotate also. So it can rotate about this axis, or like you can consider one axis is passing through this. So it can like rotate about this axis also. So it has 2 rotational degrees of freedom. Overall, it has 5 degrees of freedom. So the CV value for oxygen is 5 by 2 R. This is for O2. Now we can find the total internal energy. N1 is for the organ, it is 8. 8 into, this is 3 by 2. 3 by 2R into T plus next oxygen. For oxygen, it is 6 moles. 6 into CV, 5 by 2R into T. So this will become 4. 4 into 3, 12. 12 RT plus, and this will become 3. 3 into 5, 15. 15 RT. 12 plus 15, 27 RT. So the overall internal energy of this system is going to be 27 RT. Here we neglected this vibrational motions. we doesn't consider that the molecules vibrate. So we consider up to rotational motion. This question is related to meter bridge. So let's draw the diagram. The left side there is a resistance which is X ohm, whereas on the right side it is 25 ohm, and it is connected with a wire of length 1 meter. Consider this AB is the wire of length 1 meter. In the middle there will be a galvanometer, and another end will be connected to a jockey, and the jockey will be placed at a particular point where the galvanometer shows null deflection. So this distance is known as balancing length. So let this be L1 and this will be L2. Okay. So when the bridge is balanced, then the resistors are going to be in a proper ratio. That ratio, let's write in this way. So let this be R1, this be R2. So what is R1? R1 is the resistance provided by the wire of length AJ. So from A to J, the wire will offer some resistance, that is R1. Similarly, from J to B, the wire will give some resistance, that is R2. And it's mentioned that the resistance per centimeter of the wire is R. So let's consider this is case 1. Okay, in the first case, let's write the condition for the balanced bridge. So it is going to be X by R1 equal to 25 by R2. So X by R into L1. So resistance per centimeter is R. So R into L1 will give this R1, which is equal to 25 by R into L2. So this R can be cancelled and we can write X by L1 equal to 25 by L2. So this is the first equation. Now in the second case, the wire is getting replaced. So instead of the resistance per centimeter R, here 2R is used. So how this equation will transform will become X by 2R into L1 dash. We don't know the new balancing length. Let's consider it as L1 dash, which is equal to 25 by 2R into L2 dash. So this L1 dash, L2 dash are new balancing length. Now we can still cancel this 2R. We can write it as X by L1 dash equal to 25 by L2 dash. This is second equation. So if you look at first and second equation, then we can say that L1 dash should be equal to L1. This is the old balancing length, which is 40 centimeter. L1 is the old balancing length. L1 dash is the new balancing length. So from this two equation, we can say that both of them needs to be same. So which means the new balancing length is also equal to 40 centimeter. Two statements are given. We need to find the correct option. So whether the given statements are correct or not, we have to find it. So first statement says that electromagnetic waves carry energy as they travel through space, and this energy is equally shared by electric and magnetic fields. So based on the theory, this is correct. The total energy of electromagnetic wave is equally distributed in electric field as well as magnetic field. And second statement says when the electromagnetic waves strike a surface, a pressure is exerted on the surface. So electromagnetic wave can be treated as photons. When photons do have momentum, so when they strike a surface, its momentum changes, which means the direction of the momentum changes, or magnitude will also change. So that will exert a force on the surface, and how much force is acting on a area, based on that we can say a pressure. So it is possible to have a pressure due to electromagnetic wave. This is also correct. So which means both the statements are correct. Yeah, option 2 is the correct answer. This question is based on photoelectric effect experiment. So initially, the photoelectric effect experiment is conducted with the light of frequency. Let's consider it as F, and it is 1.5 times of threshold frequency. So F0 is the threshold frequency. So threshold frequency is the frequency above which photoelectric effect can take place. So whenever we shine a light whose frequency is more than this threshold frequency, then photoelectrons will be emitted from the material. Now in the second case, they are doing the photoelectric effect with half of the frequency of the initial one. So which means f dash is going to be f by 2. So in this case it is 0.75 times of f0. So it is less than the threshold frequency. Whenever we do a experiment, that photoelectric effect experiment, with a frequency of light that is less than threshold frequency, then we will not get any photoelectrons. There won't be any photoelectric effect at all. So in this case, the second case, we are going to get zero photons, sorry, zero electrons. In this question, we need to calculate the change in illumination, or how much the illumination has decreased as the current is dropped 20% in a lamp. So here illumination means intensity. So intensity, how do we write? Intensity is nothing but power per area. Okay, since in this case the area remains same, which means the intensity is directly proportional to power. So if we calculate how much power is changed uh, in this bulb or the lamp, then we can calculate the percentage of change in the illumination. So how do we write power? Power can be written as V into I. So here current is changing, but we don't know anything about potential difference. We have to write this in other form where only the current is a variable. So using Ohm's law, I can write this as I squared R, where R is the resistance of the lamp and it is going to be constant. So power can be written as I squared R. Now initial power equal to initial current squared into R, and final power equal to final current squared into R. So how do you write final current? Final current, from the initial current 20% has dropped. So which means it is going to be 0.8 times of initial current. So let's substitute this. Final power equal to 0.8 initial current squared into R. So this will become 0.64 initial I squared into R. So 0.64 into initial power. Now we need to calculate percentage change. So percentage change is like final power minus initial power divided by initial power into 100. So here final power 0.64 into Pi minus initial power Pi divided by Pi and into 100. So we get negative 36%. And this negative indicates that it is decreased. So already that is denoted with the word drops. We can just take this 36. So there are two vectors, A and B vector, and both are having same magnitude. Magnitude of A, which is equal to magnitude of B, and that is R. And both are making angle theta. So if this is A vector, this makes angle theta with B vector. So we need to check like which option is correct. So we know one expression, like if we add two vectors and take the magnitude, what it will be. So A plus B magnitude, which is going to be equal to square root of magnitude of A square plus magnitude of B square plus 2 into magnitude of A magnitude of B cos theta. So let's use this one. Let's check this option. So here we get magnitude of A, which is R. So R square. For B, it is R square. Then 2 R into R cos theta. So this will be 2R squared plus 2R squared cos theta. So I can take 2R squared out common. It will become root 2R into square root of 1 plus cos theta. Now there is no option which is like square root of cos theta and all. So we have to simplify this. We can use another trigonometrical identity, that is 1 plus cos 2a, which is equal to 2 cos squared a. So here 2a is this theta. So if I substitute it, it will become 2 cos squared theta by 2. So if you simplify this, you will get root 2r root 2 cos theta by 2. So this is going to become 2r cos theta by 2. So this is magnitude of a plus magnitude of b. Sorry, a plus b, its magnitude. So a plus b, its magnitude is 2r cos theta by 2. Yeah, I think third option is the correct one. So two nucleuses are there in this question, nucleus 1 and nucleus 2. Let's consider its mass number is A1 and here it is A2 and its radius is R1, here the radius is R2. Now in the question they are telling that the radius of the first nucleus is half of the second one and its mass number is 192. So A2 is 192 and R1 is R2 by 2. So this is what given in the question. We need to find A1. So radius of any nucleus we can write as R equal to R0 into A power 1 by 3, where R0 is some constant and A is the mass number. So using this I can write for R1 and R2. R1 equal to R0 into A1 power 1 by 3. Similarly R2 equal to R0 into A2 power 1 by 3. So in the question it is given R1 equal to R2 by 2. So let's substitute R2. R2 is R0 A2 power 1 by 3 and divide by 2. Now we'll substitute R1 also, which is R0 into A1 power 1 by 3, which is equal to R0 into, no, R0 by 2 into A2 power 1 by 3. So we can cancel R0, R0. We want A1. We have to cube both the sides. So it will become A1 equal to, so if I cube it, then 1 by 3, that cube root will get cancelled. And here 2 cube, which is 8, and it is A2. Okay, we'll substitute A2. A2 is 192. This question is related to escape velocity. So here escape velocity of the planet is given, which is v, and we need to find the escape velocity of the moon. The comparison of mass and diameter is given. So first of all, we should know the expression for escape velocity to solve this question. Let me write it. Escape velocity, we can write it as root of 2g radius of the moon is going to be 1 by 16 times of radius of the planet. Now we need escape velocity of moon, which is equal to square root of 2g mass of the moon divided by radius of the moon. Let's substitute mass of the moon, radius of the moon in terms of these planet values. So 2g mass of the planet divided by 44 into radius of the planet divided by 60. So this is 1 times, this is 9 times. So we get root of 2gmp divided by 9 into rp. So if we take the square root of 1 by 9, it is going to be 1 by 3 and remaining values are equal to escape velocity of the planet. So in the question it is given as v. We can write it as v by 3. This question is based on viscosity. So there is a spherical ball which has a radius r. It is falling in a viscous medium, and that medium has negligible density. So this point is much important. So here the terminal velocity is v, and in another case, same ball, I mean another ball with same mass and radius 2r, it is falling. So for this case, we need to find the terminal velocity. So since it is viscosity and terminal velocity, you are not supposed to use the expression which you have learned already, where the viscous, along with viscous force, Booyan's force will also be there. Since here medium of negligible density is mentioned, so we need not to consider buoyant force, which is also negligible. So if we consider the ball whose mass is m, then only two forces are going to act. The gravitational force will act downward, and force due to viscosity, it will act upward. So terminal velocity means the velocity at which both the forces are going to be equal. So Fg is going to be equal to Fb. In the previous case, we will have Booyan's force also, so the expression changes. Since the negligible density is given, so we need not to consider it. Gravitational force, which is mg, Booyan's force, we can, sorry, viscous force, we can write using Stokes' law, that is 6 pi eta r into v. Eta is coefficient of viscosity, r is radius, v is the speed. So terminal velocity means it's a velocity at which the net force is zero. So here the two forces are equal and they are in opposite direction. So we can just rewrite this, or maybe this mass, gravity, and all other stuffs are constant. Only this radius and speed are variable. So I can write speed is inversely proportional to radius. So in the first case, v1, the speed is v and radius is r. In the second case, let's consider speed is v2 and the radius r2. So R2 is 2R. We need to find the V2. So I can write V1 is directly proportional to R1 and V2 is directly proportional to, so this is 1 by R1, this is 1 by R2. Yeah. So V1 by V2 will be equal to R2 by R1. V1 V2. So V2 equal to R1 by R2 into V1. R1 is R, R2 is 2R, V1 is V. So V2 equal to V by 2. The terminal velocity of the second ball is going to be half of the first ball. Time-dependent force F is acting on an object having mass 2 kg. So this force vector is written as 60 I cap plus 6t squared j cap and mass is 2 kg. We need to find the power developed by this force. So power can be written as force times velocity. The force is given, we need to find the velocity. So with force, we can find the acceleration. Acceleration is nothing but force by mass. So here mass is 2 kg. So if I divide, I will get 3t I cap plus 3t squared j cap. And the acceleration, we can write it as dv by dt. Now this dv can be written as a into dt. So from this, if we want velocity v, then we have to integrate it. So integration of dv, which is nothing but integration of a into dt. So let's integrate. Velocity equal to integration of a into dt. A is 60 I cap plus 6 t squared j cap into dt. So this is going to be, oh sorry, this is force. Acceleration is 3 t 3 t squared. Yeah, this is what we have to write. So the first part is going to be 3t squared by 2 I cap plus 3 t cube by 3 j cap, which is equal to 3t squared by 2 I cap plus t cube j cap. So we got our velocity, which is 3 t squared by 2 I cap plus T cube J cap. Also we got our force which is in the question itself, 60 I cap plus 6 T squared J cap. So we can find the power now. What's a scalar quantity? Power equal to force times velocity. So we have to multiply the coefficient of I cap and J cap, or the component of I cap and J cap. So it will become 9 T cube plus 6 T power 5 watt. Fourth option is the correct answer. We need to find the output of this logic circuit. So let's consider the first gate, which is a OR gate, and its input is A and B bar. So output is going to be A or B bar. For the second gate, the A is inverted, so A bar, and B is straight away, so A or B bar. So these two are the input of this NOR gate. So let's write the output of NOR gate. It is going to be the first input A or B bar, and again it will do a OR operation, then NOT operation. Then the second input, yeah, so this will be OR gate. If there is no bubble, then this will be the output. Since there is a bubble, which means it has to do the NOT operation, I have to put the bar on the top. Now, since everything is in OR operation, I can slightly rearrange this. So I can write this as A or A bar or B or B bar. Now A can take a value either 0 or 1. So which means together these two guys are going to give always 1. Similarly together these two guys are going to give the value 1. So it will become 1 or 1. 1 or 1 is 1 only. 1 bar. 1 bar is 0. So output of this circuit is always 0. Irrespective of the input, the output should be 0. Which means third option is the correct answer. This question is based on dimension analysis. We need to find the dimension of A and A multiplied by B. So here, if we look at this expression, the dimension of B is pretty simple because it is written B minus x squared, where x is having a dimension of length. Whenever we add or subtract two quantities, they should have same dimension. So dimension of L is, then B should be L squared, because since it is subtracted with x squared, so the B will have the same dimension of x squared, L squared. Now let's figure out the dimension of A. So A can be written as B minus x squared divided by E into T. So let's substitute dimension of each quantities. Here dimension of the numerator is L squared, and energy. So energy we can write of mv squared. So based on this I can write mass, uh, then velocity meter per second, which means length by time. So L squared length squared, T power negative 2, again one T is there. So L squared will get cancelled and we left with m power negative 1, then T. This is the dimension of A. So now we want dimension of A into B. So it is going to be m power negative 1 T L square. M power negative 1 T power 1 L square. Second option is the correct. We need to find the power consumed in this entire circuit. So this circuit has some resistor network and internal resistance. So let's solve this resistor network. Let me redraw it. So we have 2 ohm resistor here, and if you see this one, these two guys are in parallel. So I can draw like this: 2 ohm and here one 2 ohm. These are in parallel. This is in series with these two guys. So again 2, 2. Here we have another 2. Now, okay, this is 2. Now, this 2 are in parallel. No? If we simplify this, we'll get 1 move. Similarly, the other one, this is also going to be 1 move. So we can again redraw this circuit. This is 2 ohm. Here we have 1 ohm, 1 ohm, then 2 ohm. So this is 1, 1, and this is 2. So if we find the total resistance of this, here it will be like 3 resistors are in parallel because this 1 and 1 are 1 and 1 are in series. We can simply add it. It will become 2. So 3 2 ohm resistors are in parallel. The resistance is going to be 2 by 3 ohm. Now this circuit can be redrawn. Instead of the network, we have 2 by 3 ohm, and internal resistance is also 2 by 3 ohm. So the overall resistance of the circuit, or the total resistance, is going to be 2 by 3 plus 2 by 3. Because they are in series, we can simply add them. It will become 4 by 3 ohm. Now we need the power. Power can be written as V squared by R. So V is 2 squared by R. R is the total resistance, 4 by 3. So we get 3 watt. So it is 3. This is an interesting question. So related to image formation by curved surfaces. There is a convex surface, something like this, and it has a refractive index 1.5, and the object is placed in front of the convex surface 100 centimeter from the surface. So from here to here, consider this is 100 centimeter, and one object is placed. So this is the object, and image will form somewhere inside the curved surface. Now this object is placed in an air medium. So refractive index of air, which is 1. Let it be n1, this is 1, and this is n2, 1.5. So we need to find the image distance from the object. Yeah, so it's not straight away image distance, but it's like distance between image and object. Fine. So if you have lens, we know how to write the equation for the image formation. That is 1 by f equal to 1 by v minus 1 by u. F is focal length, v is image distance, u is object distance. So we'll slightly modify this for the curved surface. Here, what is v? Image distance. And where the image forms in this medium, like n2. Just put this one. Refractive index of that medium by v minus where the object is placed in the air medium. So put that refractive index n1 by u. Now subtract both of them. n2 minus n1 by the radius of the curvature of this curved surface, which is r. Also, we have to follow the same sign convention. Here the object distance is negative 100 centimeter and radius is 20 centimeter. So we'll substitute everything. N2 1.5 minus N11 by R. R is 20 and N2 1.5. We don't know, minus N1. N1 is 1. U is negative 100. So 1.5 by V will become, this is 0.5 by 20 minus 1 by 100. So if I take LCM, it will become 2.5 minus 1 by 100. 1.5 by V will become 1.5 by 100. Therefore, V equal to 100 centimeter. So remember, this is an image distance, which means image is forming from this point to here. This distance is 100 centimeter. But in the question, what are they asking? Image will be formed at dash centimeter from the object. So this is the key point you have to look at, which means the overall distance of the image from the object is going to be 100 plus 100, which is 200. 200 centimeter. In this question, we need to find the induced current. Here magnetic flux is given with respect to time, that is 5t squared minus 36t plus 1. Also, resistance of the circuit is given, which is 8 ohm. So first we need to find the induced EMF. Magnitude of induced EMF is rate of change of magnetic flux. So let's concentrate on the magnitude only. Let us not worry about the sign. So we need to differentiate this magnetic flux with respect to time. We differentiate, we get 10t minus 36. So yeah, also we need to find the induced current at t equal to 2 seconds. So substitute t equal to 2, then we get the induced EMF as 10 into 2 negative 36. 20 minus 36, 16 volt. So induced EMF is 16 volt and resistance is given, we need induced current. Using Ohm's law, we can write uh, the current as EMF by resistance. So 16 by 8, which is 2 ampere. This is 2. This is an interesting question. We need to find the longitudinal strain of this wire. Its radius is given. Radius of the wire is 4 into 10 power negative 5 meter. Young's modulus is given. Young's modulus is 2 into 10 power 11 Newton per meter square. Yeah, we need to find the longitudinal strain. So how do we write Young's modulus? Young's modulus is stress by strain. So if you want strain, then it is going to be stress by Young's modulus. So in physics, stress is defined as force acting per unit area. So the strain will become force per area here, Young's modulus. This force, how this wire got the force? Because of the tension. So I can write this as tension by area into Young's modulus. So we need to find the tension in this wire. How do we find it? We need to draw the free body diagram. So for this 2 kg, the tension is going to act upward. Yeah, heavier block will move downward. Let's consider it is moving downward with acceleration A, and this will also move upward with acceleration A. So tension here is upward, and here also it is upward. Same tension because same wire. So let's use the Newton's second law and write the equations. For the 2 kg mass, it is going to be T minus 2g. I'll write mg instead of m into g. I just wrote 2 into g, which is equal to ma, that is 2a. For 4 kg, the gravitational force is greater. So 4g minus t, which is equal to 4a. So let's add these two and find the acceleration. Substitute that acceleration in one of the equation. We'll get the tension. So if we add them, what do we get? 4g minus 2g, which is equal to 6a, and a is going to be g by 3. So we got the acceleration and substitute this acceleration in the first equation maybe. Let me do that here. A equal to g by 3. First equation is t minus 2g equal to 2a. T minus 2g equal to 2a. So t is going to be 2g plus 2a. So which is 2g plus 2g by 3, which is 8g by 3, which is equal to 80 by 3. So we got our tension. Tension is 80 by 3 Newton. Now we can find the strain. So strain equal to tension by area into Young's modulus. So tension is 8 by 30 area. Here cross-sectional area of this wire. So you can consider this wire as a small cylinder. Cross-sectional area is going to be a circle and it is pi r square. Pi into r. R is 4 into 10 to the power negative 5 meter square. Young's modulus 2 into 10 power 11. So let's square it. This will become 16 into 10 power negative 10. This is 2 into 10 power positive 11. So this will be 10 2 and this is 5. So we get 5. That 3 will go down 3 pi into 20. This is negative 10, 11. So 20, 1, 4. So we get the strain is 1 by 12 pi. In the question what they gave, 1 by alpha pi. So value of alpha should be 12. In this question, we need to find the angular momentum of a mass which is projected with speed u. So let's consider this is the ground and the mass is projected in this way with initial speed u with angle theta. Here theta is 45 degree. So the object will exhibit projectile motion and we need to find the angular momentum of the object with respect to the point at which it is projected and also exactly at the point where it is having the maximum highest point. Yeah. So let's consider this height as h max and this is the point from which it is projected. So initially it has a speed or velocity u. This velocity can be split into two components. One is vertical component, it will become u sine theta, and horizontal component, it is going to be u cos theta. So at maximum height, the vertical component becomes 0. So only velocity remains is the horizontal one, that is in this direction, u cos theta. So how do we write the angular momentum? Angular momentum we can write it as uh, r cross p we write like, or if you want the magnitude only, then we can write it as r perpendicular into p. So what is r perpendicular? It is a perpendicular distance between momentum and axis of rotation. So here axis of rotation is this point. You can consider axis of rotation is passing through this point, the point at which it is projected, and it is going into the screen. So the perpendicular distance becomes h max. R perpendicular is h max in this case. So at highest point, the angular momentum is going to be h max into m into u cos theta. Now we need to find the h max. So we can use equation of motion. Initial velocity we know, final velocity we know, like I'm talking about the motion along y-axis. Then we need to find the displacement. And here we know acceleration is downward and it is g. So we can use the expression that is v squared minus u squared equal to 2as. So here v is the final speed which is 0 and u is u sine theta. So it is u squared sine squared theta and acceleration is negative g. So negative 2g h max. So h max will become u squared sine squared theta divided by 2g. So we can substitute everything to find the angular momentum h max, that is u squared sine squared theta divided by 2g into mu cos theta. And we know theta is 45 degree, which is given in the question. So cos 45 sine 45 are equal to 1 by root 2. So I can write this as mu squared 1 by root 2 squared, here 1 by root 2 whole divided by 2g. So what do we get? Mu squared divided by 4 root 2g. This is the angular momentum in the question. Root 2 is there on the top. So what I can do, I can multiply and divide with root 2. So this become root 2 mu squared by 8g. So if we compare with the question, it is written root 2 mu cube by xg. What will be x then? Going to be 8.
There are two coils P and Q, and they are having 100 turns. So number of turns is 100. Radius of the coil is 5 centimeter. It means pi into 10 power negative 2 meter. So in coil P, the current 1 ampere is flowing, and in Q, 2 ampere is flowing. So IP it is 1 ampere, in Q it is 2 ampere. So it should be. Now these coils are placed mutually perpendicular to each other. Means their planes are mutually perpendicular to each other, and we need to find the resultant magnetic field at the center. So you see, like one coil is placed in this. Let's consider the current is flowing in this direction. Let it be IP. You have to think that it is going into the screen, and another one will be placed something like this. This is also going into the screen. We are seeing from the side. It will be like this. Now, due to this coil P, based on this current direction, the magnetic field is going to be downward, and due to this Q, it is going to be towards the left. So it is so clear that these two magnetic fields are going to make angle 90 degree, and we need to find the net magnetic field. So the net magnetic field will be square root of BP square plus BQ square. So let's find this BP and BQ separately. First of all, like if you have a coil and if some current I is flowing in that coil, the radius of the coil is R, then magnetic field at the center is mu naught I by 2R. In case if it has n number of turns, then you have to multiply with n. So using this formula, we will find it. BP is going to be mu naught IPN divided by. So mu naught is 4 pi into 10 power negative 7, and IP is 1, and is 100. Here 2, R is pi into 10 power negative 2. So if you cancel, you will get 2 into 10 power negative 3 Tesla. Unit of magnetic field is Tesla. Do the same thing for the next coil Q. So mu naught IQN divided by 2R. Mu naught again 4 pi into 10 power negative 7. Here current is 2 ampere. IQ is 2 ampere. In 100, this is 2 pi into 10 power negative 2. So this will become 4 into 10 power negative 3 Tesla. So we want the total one, which is BP squared plus BQ squared. This 10 power 3 is common for both, so it can be taken out 10 power negative 3. Then you will get 2 squared plus 4 squared. So it will become 10 power negative 3 into root 20. So this can be written as root 20. Instead of 10 power negative 3, we can write the millitesla. When we compare with the question, written root x millitesla, root 20 millitesla. So the x value should be 20.
Certain charge distribution is given. We need to find the electric potential due to this charge distribution. If we look at the charges carefully, like one negative q and positive q is there, so this will act like a dipole. Similarly, plus 2q, negative 2q is there, that will act like another dipole. So we need to know that what will be the electric potential due to a dipole. So there is an expression for it. So let's consider this is the dipole moment, direction of the dipole moment, and this is the origin of the dipole or center of the dipole. So from this, at r distance, if you have a point, at this point, the electric potential can be written as K P dot R divided by R cube. If I expand it, it will become K P R cube cos theta. So this will become K P R cos theta. Sorry, R squared cos theta. Okay, so of course here r vector direction is like this. It is connecting the origin and the point where we want to find the electric potential. This will be the theta. So let's figure out the dipole moments due to this charge distribution. So first, when we look at negative q and positive q, the dipole moment is from negative to positive charge. So it is in this way. It is P1 and its value is charge times distance between the charge. So Q into 2L. Similarly, if you look at plus 2Q and negative 2Q, the dipole moment direction is this way, and let it be P2, and this is 2Q into 4L because distance between the charges are 4L. So this is 2QL and this is 8QL. So the net dipole moment, which will be in this direction, and its value is going to be, since both are opposite, we have to subtract it. It will become 6QL. This is the net dipole moment direction. So let's redraw this figure. This is the net dipole moment, and this is the origin, and we have R. At this point, we want to find the electric potential. So let's write K P R squared cos theta. So it's important to find the theta. This will be the R vector, and it is an angle between two vectors. So which means now this becomes our angle theta. See here the question, if this is 60 degree, this will be 120 degree. So theta is 120 degree. So let's substitute everything. V equal to K. K is 9 into 10 power 9. P is given 6QL divided by R squared cos 120 degree. Cos 120 degree is negative 1 by 2. So this will become 3. So negative 27 QL R squared into 10 power 9. This is what we are getting as a potential. Let's compare with the question. It is written negative alpha QL by R squared into 10 power 9. If we compare, alpha is going to be 27. So this is 27. Two spheres are there which are connected by a light mass, a light rod with light mass. So let's consider these are the two spheres, and mass of the sphere is m. This is connected with the rod, and the rod is having uh, no mass because it is mentioned light rod. So we can neglect the moment of inertia due to the rod. So mass of the sphere is m, which is 2 kg, and radius of the sphere is given, that is 50 centimeter. So this distance, this is 50 centimeter. So radius is 50. I can write it as 1 by 2 meters, and distance between two centers is 150 centimeter. 150 centimeter. Now we need to find the moment of inertia about this axis, which is perpendicular to the rod and it's in the middle point. So this is where we need to find. Fine. So if we have a sphere, since they haven't mentioned what sphere it is, by default we can consider it as a solid sphere. So let's consider a solid sphere. If we find the moment of inertia about an axis which is passing through center of mass, then it is going to be 2 by 5 mr squared. Now we want to find the moment of inertia about this axis. So let's consider this axis is, say, for d distance away from this axis which is passing through center of mass. So we can use parallel axis theorem and we can say that moment of inertia is ICM plus md squared. So this is based on parallel axis theorem. Now this is due to only one sphere. Since we have two spheres and they are identical, like they are placed in the same way with the same mass and radius. So the total moment of inertia is going to be twice of this one. I total is twice of I dash, which is equal to 2 into ICM plus md square. So here d is half of this 150, so 75 centimeter, which can be written as 3 by 4 meters. It is more important to convert everything into meters because in the question it has mentioned kg meter square. So let's substitute I total, which is equal to 2 into ICM, that is 2 by 5 mr square plus md square. Let's substitute the values. 2 by 5, mass is 2 kg, radius is 1 by 2 meter square, 1 by 2 and square. Again 2 kg, this is 3 by 4 square. So this will become 4 by 5 into 1 by 4 plus 2 into 9 by 16. So 4, this will become 8. So it is equal to 2 into 1 by 5 plus 9 by 8. So if I take the LCM, it will be 40 into 8 by 45. So this I can cancel. 20, 53 by 20. So total moment of inertia is 53 by 20 kg meter square. In the question it is given x by 20 kg meter square. So x is going to be 53. We need to find the time period of this simple harmonic motion. So mass m is exhibiting simple harmonic motion. We need to find the time period. So if you have a simple spring mass system, so let's consider this is spring constant k and it is connected with mass m. So in this case, the angular frequency is written as root of k by m. So angular frequency is nothing but 2 pi by t. So time period we can write 2 pi root of m by k. So what we have to do is we just need to find the equivalent spring constant for this setup. So when the springs are connected in parallel, we just need to add them. The equivalent spring constant is addition of both of them. Here you see these two things are connected in parallel. If we replace this, then it is going to become 2k. Now this 2k and k are in series. So in series, we have to take the reciprocal and add it. 1 by 2k plus 1 by k, which is going to be 3 by 2k. So instead of these three springs, which is on the right side, we can have a one spring whose spring constant is going to be, let it be k dash, it is 2k by 3. So we can replace this entire setup with the spring constant, which is 2k by 3. Now this 2k by 3 and this k are in parallel. So the overall spring constant is going to be k total, which is 2k by 3 plus k. It is going to be 5k by 3. So this is the overall spring constant. Now time period, let's write t equal to 2 by root of m by k total, which is 2 by root of m by 5k by 3, which is equal to 2 pi root of 3m by 5k. So in the question they have written pi into root of alpha m by 5k. So here it is pi, but here we have 2 pi. So I'll bring this 2 inside the root. So it will become pi into 4 into 3. So if I bring this 2 inside, I have to square it. 4 into 3 m by 5k. So which is equal to pi root of 12 m by 5k. In the question it is given t equal to pi into root of alpha m by 5k. I think it's correct. Yeah, pi into root of alpha m by 5k. And what we got? Pi into root of 12 m by 5k. From this I can say alpha equal to 12. So there is a nucleus with mass number A1 and its volume is V1. And another nucleus is there, its mass number is A2, its volume is V2. And relation between A2 and A1 is given. That is A2 equal to 4 times A1. And we need to find the relation between V2 and V1, that is V2 by V1. So we can consider the nucleus as a sphere. Volume of the sphere is 4 pi 3 pi r cube, where r is the radius of the sphere, radius of the nucleus. So here radius of the nucleus we can write it as r0 into a power 1 by 3, where a is mass number. So let's substitute this r here. R0 is a constant that we know. So 4 pi 3 pi r0 a power 1 by 3 cube. So this will become 4 pi 3 pi r0 cube a. This is the volume. So here 4 pi 3 pi r0 cube is a constant. Only variable is a. So we can say volume is directly proportional to mass number a, which means we can write v2 by v1 is equal to a2 by a1. So a2 is 4 times a1. 4 times a1 by a1. A1 will get cancelled and we will get 4.